So next up is Mr. Esko Pettay. How do you pronounce Pettay? Okay, yeah. And he's gonna talk about the food in closed circulations. Esko has been involved in such a project, and he will share the experiences from that. So yes, please welcome.
Thank you. So my name is Esko Pettay. Studied biology, but has worked as an environmentalist and an environmental expert for quite some time now. But here I represent. I had to choose some organization, so I decided to choose our think tank foundation, Atmosmare Foundation. So I'm not representing any of the businesses described in this presentation. I hope it gives me some freedoms. So first I start by telling what was our motivation to start thinking about these issues, producing food in closed circulation, and especially fish. It was protecting the Baltic Sea and especially preventing eutrophication. As this is my late addition to my presentation, so we wanted not to spread phosphorus around. We have been, and when I say we, I mean all the people involved in this project, several businessmen and so on. We have been very worried about climate change, and that was one of the greatest motivations in this project also, about the prevention of it and also preparing for climate change. We even had some talks about trade deficit when we thought about food production and bio oil production, which is part of this project. We wanted to prepare for more extreme weather, and of course we wanted to reduce fossil fuel use. And my personal motivation in about everything I do comes from this chart or this graph. That is the defining thing that motivates my actions. So then we had an idea how to circulate everything that circulates and produce food and energy. We have a closed circulation system which includes a biogas plant which is using organic materials and also gas from nearby landfill. With that biogas, we are running a generator, which is, of course, producing electricity, CO2, and heat. We can use all those in our fish farm, in our greenhouse, and we can use some of the leftovers and residues in biofuel or bio-oil production, or part of it in a biogas plant. So that was the idea when we started working on this about 10 years ago. So, luckily we had a spot in Uusikaupunki where there is a landfill, and nearby we were able to build our facilities. So, there is a biogas plant producing 2 megawatts thermal power, and luckily, since I was participating in this project when we had the ideas, when we started working on it, but once it went further in the hands of engineers, I dropped out of it. So I'm not expert on any of the exact numbers, so I got to get the best part of this project. All the phase when we get to trade ideas, but all the technical difficulties were left on the engineers' hands. But anyway, biogas plant, fish farm, which is nowadays producing almost 300 tons of fish per year, whitefish and rainbow trout. Very low water consumption, so the water is circulated quite efficiently. and all the water that is discharged from this facility goes through a wastewater treatment plant. So I really think we did well regarding eutrophication. There's hardly any nutrients flowing to the Baltic Sea from this fish farm. And the greenhouse on top of the fish farm. We also have a bio-oil plant, which is originally used only fish guts, which are high in oil content, but nowadays it is also used cooking oils or some waste from slaughterhouses. Basically anything that contains oils or fats can be turned into bio-oil. So this is, since we're talking about food, this is the main product at the moment, whitefish, and about 200 to 250 tons per year. I will not go into the technicalities of farming whitefish, but this, of course, sells with a slightly better price than rainbow trout. So that's one of the reasons why it was chosen. It is slightly more difficult to farm, but we have two species that we are producing there. Then there's the greenhouse, and this list I got from the manager of this operation about the pros and cons of this project. So we are able to use CO2 in the biomass growth. It is energy efficient when we are able to utilize excess heat and so on. We are also selling the heat to nearby businesses, since it's actually producing quite a bit of heat, the generator. Doesn't need that much manpower, since it has joint operations, a couple of operations running on the same area. Very low water use, and of course these kind of projects have high public interest value. We have had plenty of visitors on this site during the years. Well, some of the, I would call them problems, actually. Need of know-how. This has been, so I'm told, quite tricky project to actually combine these facilities and really make them work. The investment costs are relatively high. Then some technicalities, which I will not go into. Also, some contamination always possible in such a closed system and a fish farm, so it needs to be dealt with. And some technical difficulties, and before I forget, one example is this summer, which was, well, the hottest summer in Finland ever, and it caused some problems in the fish farm. It's the cooling system was running too high, and there was some malfunctions and some a little bit of loss of fish during this summer due to high temperatures, and that's something that needs to be taken into account, since one of the pros of this kind of operation would be that it's sealed against extreme weather. So we need to make sure that it actually happens. My own topic has been more closely related to bio-oil production. In the same system, we have a bio-oil production. It has been running more than 10 years now. Originally, as I told, used fish guts, especially rainbow trout guts, and we produced biodiesel. But later on, we decided that we are going to produce bio-oils for shipping, as our mother company is a shipping company, and that's where I actually work nowadays. But big chunk of our raw materials is now, for example, Hesburger hamburger joint used cooking oils, then the fish oils and other materials. I'm myself quite pleased that we are not using anything that could be or would be edible. We are not competing with the food production or anything. So these are so-called good raw materials for biofuels. All the raw materials are sourced in the Nordic region, and we have made a study about the actual emission levels and taking into account all the logistics of transporting the raw materials and so on. The CO2 emission calculated is 75% lower than with fossil fuels. Of course, that calculation considers that otherwise the oil would be turned into CO2, or the materials would rot somewhere in the landfills or so on. And some photos of from the production of the bio-oil. This was the first vessel that we tested our bio-oils. That's about 7 years ago, I believe. And this, for example, this is one of the newest vessels that is actually using the bio-oil nowadays. It was launched 2 years ago. This is her sister vessel, also capable of using bio-oil. Also, this was almost exactly 2 years ago. Unfortunately, we don't have enough raw material to operate these vessels with bio-oil all that much. But as often as we can. Part of our oil production actually goes to as a heating oil or a technical oil. But back to food production and the closed circulation system. My worries are regarding the environmental impact, the construction. There's a lot of concrete cement used in the production, which of course means CO2 emissions. Another negative thing is that the fish feed that we are using is not from the Baltic Sea. That would be quite optimal to reduce or remove nutrients from the Baltic Sea and use that as, commercially low-valued fish that could be fed to our fish in this facility. In our case, we are energy independent and of course also selling energy outside and using only biomasses to produce the energy. One of my hobbies is reading old newspapers. I have a huge pile of those at the summer house, and it quite often seems that nothing is new. There's an article about artificial cow and how to produce milk in that system. Scientific, cow house from 1930s, using electricity to improve growing of vegetables 100 years ago. All kinds of greenhouse operations from long time ago. I must say that LED lights, that's something new. That wasn't written in those old newspapers. But on the other hand, recycling nutrients, that is something new. The circular economy was the thing. Every farm, I believe, was based on circular economy and recycling nutrients before we had artificial fertilizers or fossil fuels. It was all the energy came from nearby and everything was recycled. But I have just gathered some photos and pictures of old farming or fish or food production. This is about 1,000 years old picture where they had a fish pond on the backyard and were able to feed the fish with the leftovers and so on. So, but some photos that the thing is actually existing. So this is in Uusikaupunki. You can see some photos from the construction. This is the biogas plant. This is from you can see where it's from. I think the company that is working there is actually a competitor of the earlier presentation. Highly specialized production, but of course myself, need to point out that it's really low caloric value, the products that can be produced in such a place. But we are able to use CO2 and energy from our own facility. We produce our own rainbow trout fry, but whitefish is bought from local producers. This is one of the drawbacks. We have to use artificial or commercial fish feed. But just to give you some idea what it looks like, a lot of concrete. Unfortunately, some CO2 emissions when building a thing like this. Then from our production, taking photos under artificial strange wavelength LED lights is quite tricky. The lights are quite strange. But my points are that we are relatively isolated from extreme weather. I hope so. Then I'm worried that we are dependent on sensitive technology that needs to be improved. Ideally, such systems would be built inside existing buildings, old factories or so on. Our system falls outside the normal agricultural subsidy system, so the financial part is quite difficult. And it's actually quite complex system. For a biologist, it has been fascinating to see something like this actually appear during the years, and it's actually working. Then some pessimistic words that we are heading towards a terrible future. Emissions are growing, and that is something we need to take into account when we are talking about food production. Population also is growing. And I have a question for the audience. Can we scale up such closed systems? Can we build them efficiently? Can the costs ever be low enough for them to actually make a huge difference in our global food production? What is potential of a circular economy in general? That's as I work in a logistic company, I always think and realize how much it consumes energy to transport all the different things that are needed in circular economy. And then, of course, one question: how are we going to produce food in 4 to 5 Celsius more or warmer world? And that's actually where we are heading right now. So these were my questions to the audience. And then in this presentation, I followed a rule from a 100-year-old magazine telling that numbers and statistics are the most boring thing one can think, and it's better to have some photos. So I tried to follow this advice. Thank you.
Thank you, Esko. Fascinating. I was totally personally amused about that. Is there anything new? And oftentimes it is that there is nothing new. So. Surprisingly so. Any questions to Esko?
Do you have any? I mean, this circular economy and these sort of things is very much like in vogue today. I was wondering, I mean, it occurred to me that are you aware of any studies, like, or maybe somebody else, on biology, that how circular are actually those sort of like biological systems? Because I would imagine that some stuff ends up in the bottom of the oceans and so on. That I mean, that can we somehow actually compare that how well does how circular is nature actually? In this
I wouldn't. Don't know the answer to that one. No.
Well, that depends on your time scale. You take a geological time.
Yeah.
It's like the Earth is a closed system target. Let's say 900 million years.
Just to comment to integrates, I think your idea is quite much right and very, very fascinating. Problem with what I've been thinking, which is existing in our agriculture, is the let's say concentration or specialization. Animal production, crop production, vegetable production, everything is concentrated on one side or separately. And this creates a lot of problems when we think about the circular economy. And I think we need to rethink the whole concept, how we are producing food, in for example, in Finland or globally. We need to think about this nice interface where we can, let's say, really circulate the nutrients, for example, and energy.
Yeah. And this is a concept that we have had discussions well, to actually import the idea to some other areas, and with no luck so far. But I can imagine that after some time, when we can, really fine-tune everything, it will be a good product. But in general, I'm quite skeptical about the material use in projects like this. In relation to the end product, there's a lot of material needs during the construction.
Here's
There was this
one more.
recent article in the Finnish newspapers that what would happen to food prices if all the subsidies and stuff like that were eliminated. Do you think that this would be how much more competitive commercially if that would happen? You mentioned that this doesn't receive any kind of support.
Well, I can't say how much. It would be more competitive, yes.
No idea.
No, but I've no numbers.
You should
Yeah.
study that.
I should. I know. Yeah.
Okay, there was one more question, and then we have the next speaker.
So one question. What would be, if it's, I don't know if it's possible, it'd be really interesting to see the numbers kind of. Whenever I'm looking at images like this, when I'm immediately thinking that okay, the biogas plant produces like how many tons of CO2, and how much of that can realistically be dumped into a greenhouse.
Yes.
But the plants just don't grow that fast. But one.
Yeah. That's a good point. I wasn't making the point in the sense that it would actually reduce the emissions of the biogas plant. It's just that we get. Yeah, I know that. It's very minuscule part of the CO2 produced. Yeah.
Related to that one, I was thinking that have you considered using algae?
Yes, we have.
Part of the solution?
Yeah, yes, we have. And originally it was planned that all the wastewaters coming out of this facility would go into a pond with algae, and that algae would put into the biogas plant again. Okay. Yeah, but so far we haven't done it. There has been plenty. Yes.
Respect.
Yeah.
Okay. Thank you.
Yes.
Voitko laittaa, niin saat sen.